Good morning.
Hello, everyone. How are y'all?
Good. How about you?
Not too bad. Got people trickling in as we speak. I'll wait till a few more get in. I want to go ahead and tell you guys that the average for the midterm was about what I expected. It turns out, normally in this class and the 132 class, your online tests average in the mid 80s to lower 90s. And then the midterm, which is your first shock at taking a test without your notes and without internet searches and that sort of thing, even though it's timed. And it turns out those tend to be sometimes in the mid 50s up to the low 60s. I've even seen them lower, but that's usually what the deal is. So if your grades are in that range for the midterm, that's not great. I mean, I'm not saying it's good or anything. I'm just telling you that that's pretty normal. And my students don't fail usually. So I think I've maybe had 2 people fail in the last 6 semesters, and both of those were people that just like missed a couple tests and stopped coming or stuff. So generally, people can get C's or at least a D, which works for a degree here, but just doesn't transfer. But I don't want people getting D's either, because that just means you got to go take another science class when you get to the next place if you actually transfer. So right now, I just want y'all not to panic. If you made within 5 or 8 points of a 60, or excuse me, of a mid 50, then I would say you're probably not great, but you can still do quite well. And not only that, later on this semester, I offer you guys some ways to help that midterm score. So what y'all need to do is learn how to study and learn how to learn, as opposed to just learn how to looking up stuff and do that. Someone have a question?
Hey, Professor Younger, I thought I was about to say, I thought class was going to be canceled today, the lecture part.
Oh no, I actually went to the wrong class. That's what happened. I had already prepped for 131, your astronomy class, so I started prepping for physics 241, which is a calculus-based physics class. So then when my alarm went off saying it's 5 minutes before class, I waited a couple minutes because I was in the middle of something, and then I immediately went onto the course, clicked on it, and clicked on the Zoom session, and realized I was in my 241 class instead of my astronomy class.
Professor Younger,
Yes.
since we're going to have a storm today, we're likely going to have static electricity, some
Yeah.
interference with the connection.
Yeah, that could happen. Right now, at least in our area, it's clear. But of course, I don't know what's slightly north of me. I think the storm is supposed to be coming from the north to the south. So,
No, it's right now it's right under us.
oh, okay. So it's actually south.
So if I lose connection and I don't get caught back, it's because of the storm. And I mean, every time
That's no
it's
big
high
deal.
winds, no matter even if you have a wired connection,
Mm-hmm.
the winds will just rip and I will lose service. It doesn't matter. So
Well, don't worry too much if you lose it. Today's lecture, I'm just going to be talking about global warming, which I'm going a little deeper than your book does, just because I want you to be educated people about the science of anthropogenic climate change and climate in general. So this is sort of an add-on to chapter 9. And not only that, we have lab today, and I've already put the lab assignment there. I'm going to show up at 1:30 like we're supposed to, but you're going to that's going to be a time for you to ask me questions, and then you can just leave. I'm not even necessarily going to take attendance, but I'm going to be there to give you the time if y'all want to ask questions, because this week's lab are 2 assignments out of your textbook that you're supposed to do on your own. If you need any help, you should maybe bang some ideas off of other people in the discussion boards, or just send me an email and ask me. So I've already posted that assignment in your lab page for those of you who have me for lab. Not only that, I give you the opportunity by doing these 2 problems, or problem and problem set from the textbook. I give you both a chance to get 200 astro points for one of them and 100 astro points for the other in your lecture. And then it also counts as a lab in your lab. If you have someone else for lab, they may or may not be interested in doing something like that for lab, but that's what we're doing. Anybody in here right now have someone else's lab?
I do.
I do.
Gotcha. I heard Amy Sigmund. Who was the other person?
Liana.
Okay, got you. It normally shows this little thing over to the right who's talking, and yours didn't come up quick enough. So Leanna, all right. Your instructor, I don't know if they even do a point type system in their lab class, but you can just let them know that you're doing this or whatever, and they might be interested. And tell them if they want. I can give them the. Actually, no, I can't, because this class I did it on the other class. I was able to actually use it as a smart work assignment. So I looked for the explorations at the end of chapter 14, or excuse me, for you, the end of chapter 9. And they haven't rendered those as online questions yet. So I couldn't do that with your class. So it probably won't help you to mention it to your lab instructor at all. But for my lab, you're going to get to do that. And if you want to do it for my lecture, you can still do it and get the Astro points. Okay. All right. Any other questions before we get started? I will be working on the test to check on that. I sent out a couple of emails last night. I think I had 7 people completely just missed the test because they didn't practice test stuff first. So, that was the other class. What am I thinking? Never mind. Y'all had yours before the semester break, the spring break. So scratch that. Anyways, I will talk to that next class about that, and I will give them some strongly worded warnings. So today we're going to talk about global warmings, and I'm going to start off with a parallel. I'm going to start off with a parallel that is basically the ozone decline. If you watch a particular episode of the new series of Cosmos, you'll see another wonderful parallel, and that one happens to be about leaded gasoline. Lead was used in everything up until the 70s, when a lone geologist started. He was a chemist and a geologist. He started noticing that basically lead was everywhere, and he tracked it down and found out it was coming from lead in our gasoline. And he basically started the movement that got us using what y'all now see. And when you go to the gas station, you always see unleaded. You never see anything that doesn't say unleaded. And that's kind of weird. I think we eventually just transitioned to calling it petrol or something like that, like they do in Great Britain. But it's left there. I used to have a car that only ran, or that ran better at least, on leaded fuel. That was a 1968 Mustang. So when I first got my car, I was running around buying even cheaper gas. I was buying the leaded gas, which was a little bit cheaper than the unleaded gas. But when they stopped finally having leaded gas pumps, which I want to say was maybe 88, 87, something like that, then I couldn't find leaded gas anymore, and my car didn't run so well because it actually stopped NOx. So if you want to watch the episode of Cosmos, you can see yet another story, and it very much parallels the ozone story, and it very much parallels the global warming, specifically anthropogenic global warming. So let me get started with that if no one has any more questions before I start. All right, I'm going to try to share my screen, and here it is. So this is a PowerPoint I made some time ago, and I still alter it from time to time. I updated it last time in June of last year, so it's not that up to date. And not only that, if you're paying attention to carbon parts per million, it's actually changed quite a bit even since this was done in June 2020. So the actual parts per million count of carbon dioxide is now even higher. I think it's up to 419, 420 or something like that. So it's pretty severe, but let us get started. I want you to, hopefully you guys have thought about this, or y'all heard some news. Actually, what I find is my students normally are completely believing and understanding, or at least believing the situation. I don't know that they actually know the details. They just sort of, though they're not necessarily as trustworthy as previous generations, they're somewhat trustworthy with regards to this, because most students tend to do know that this is a real thing and something that we got to deal with. Whereas older generations, my generation and before me, are not so certain. So I think it's always important to do this. Every astronomy text has a section on this. Just about every geology text has a section on this. So we're trying to do the same thing just to make sure people understand the dangers, and it's actually really good science to understand. So I'll start off with asking these questions. Why does it matter if the ozone is depleted or the globe warmed? And the answers are: ozone depletion and global warming have significant long-term risks. I like this word here, usufruct. I got it from the Thomas Jefferson Hour. The earth belongs to the living. It belongs to us only while we are living. Therefore, it is ours in usufruct. We are free to use it to live and profit, but are not entitled to destroy its productivity, its fruits. And that's where you can see the origin of the two words for future generations. Another analogy to that, than just saying usufruct, is the idea of you, in olden times, you'd walk into a town and there would be a well. And this is the kind of well that you'd have to like pour water in it and then pump it because the water primes the pump. And then you pump it and then water comes out and you fill it up and then you leave a cup of water on there. If you don't do that, if you drink it to the last drop and leave an empty cup, then the next person that comes along can't actually have water because he can't prime the pump. So the responsible behavior is to come into town. If you want some water, drink the water, that's fine, but fill a cup and leave it for the next person. That's sort of what's going on with this. We're not doing it. Okay. We're doing some damage that future generations are going to suffer from. So it's probably just from a moral standpoint, that's a good reason not to do it. Ozone depletion has immediate health and safety consequences, and global warming has immediate health and safety consequences. We'll talk a little bit about that specifically later. But let's start off first talking about this ozone depletion thing. Have y'all ever heard of the ozone hole? Anybody?
I have.
Yeah, it's
The ozone hole?
yeah, there's a hole in the ozone. So the ozone's like in the upper atmosphere, the stratosphere area, like we talked about before. And it's a layer of O3. Literally, oxygen bonds with oxygen normally and makes a diatomic molecule, O2. But in certain conditions, it'll actually bond with a third oxygen molecule and make ozone, which is O3. And that thing happens to vibrate at just the right frequency where it can actually absorb UV radiation. And UV radiation, you know, gives us suntans, but it also gives us skin cancer, melanoma, that sort of thing. So the ozone layer up there is highly protective of us, and it's a very, very scant element. As you'll see, it's a few parts per million. Actually, it's way less than a few parts per million. And so it's such a small amount. And then if you put anything in the atmosphere that can actually take that out, that could be a problem. So that's what I'm talking about. It's in around the southern pole. In fact, Australia has been dealing with it for about 20 years now. If you ever watch the Australian Open in tennis, you'll see they are like crazy wearing zinc oxide all over their whole face. You know, that white stuff like you used to see with lifeguards, like I used to do on my nose. But then they always have these big hats and they're wearing long sleeve shirts and stuff like that. That's because they really have been hit by the ozone hole because it was closest to them. But it was spreading. So 10 to 50 kilometers above Earth is a thin, wispy layer of ozone that, if removed, most life on Earth would cease to exist. Meaning, if it was completely gone, the UV radiation would be intense enough that in somewhat short order, a lot of us would just die, okay, due to various cancers and whatnot. The ozone does protect us from UV radiation, and that's the main reason we need it. It's also a greenhouse gas, which we sort of need, but as you'll see in the next section, we've got plenty right now. In 1928, General Motors first synthesized the chemically inert chlorofluorocarbons. Notice that word: chloro for chlorine, fluoro for fluorine, and carbon for carbons, for its Frigidaire refrigerators. That's the Freon stuff we were talking about yesterday or last time. In the 1940s and 50s, they were used because they thought they were so chemically inert, they thought they were really harmless, so they used them in everything. In fact, you can make a liquid CFC, and I've actually seen demos where they take an aquarium full of liquid CFC, and then they take a plugged-in computer and monitor and stick it in completely submerge it in that CFC liquid, and you can still use the computer. I mean, it literally is that inert. So you think it's really wonderful. So they started using it for everything. Hey, you need some high pressure gas to push out hairspray or armpit deodorant or whatever. We can use that with Freon, blah, blah, blah. So that's basically where it all went crazy, because we started making so many CFCs because they were being used everywhere that it really became a problem. So in 1974, scientists started investigating where are these inert gases going. So when you put, for instance, nitrogen on the ground, as we do to fertilize our grass, for instance, especially at golf courses, that is not inert. In fact, nitrogen, when it's in that state, like you do for, well, in N2, it's almost inert. That's why I told you it's used for AMPHO and those other explosives. But nitrogen in the form of fertilizer is not inert, and it attaches to water and runs off into the waterways, and that actually causes problems with sea life and stuff like that. This doesn't do that. So we thought pretty good because it wouldn't run off into the oceans like that, but we didn't really think it far enough along to figure out, well, where will it be going? Will it be sinking into our water table? Is that a danger? Or will it be eaten by animals? We don't know. So the scientists started wondering, being chemically inert, they are not broken down or rained out in the lower atmosphere. They just build up somewhere. In 1974, chemist Mario Molina, the guy on the left, and Sherwood Rowland, the guy on the right, suggested they may still be intact in the stratosphere, which is 10 to 50 kilometers overhead. And if that's the case, there'll be decades worth of it, because slowly but surely it's going to go up into that atmosphere. And we've been putting out so much, you'll have a ton of it up there. They also theorize that high energy solar UV radiation will eventually split the CFC molecules apart. So that's not necessarily good unless we know exactly what, when it splits apart, what those things it splits into does. This was alarming because chlorine, the first C in CFC, reacts strongly with ozone. Uh-oh, things are getting bad. But you might say, and this is what I said too when I first started hearing about global warming, I didn't know enough about science to make any really good decisions about ozone when I first heard about it. But when I first heard about global warming, I was pretty confident there was no way that us humans are big enough or critical enough to do anything to our huge Earth. For instance, I've done calculations. You know, if you put the entire population of the world's human beings in, you know, say in Kansas, and put them right next to each other and perfectly synchronized them all jumping, and they all jumped at once, you would barely feel a tremble of the earth. So I know we're sort of insignificant compared to the earth, and that's what most people thought about everything. But frankly, the answer is no. So here's the composition of the atmosphere. As you all know, about 78% of the atmosphere is nitrogen, about 20.9% is oxygen, about 0.9% is argon, leaving or accounting for 29 or 99.964%. Then there are trace gases. Notice the CO2, isn't that cute? Parts per million, 377. This was 10 years ago. We're now at 420. Okay. So we've literally went up by like 50. Okay. A little less than 50, but still. Water, on the other hand, goes from 20 parts per million to 20,000. But as I told you before, that's humidity, and we have to have the water. So there's nothing you can do about that. Neon's about 12 parts per million. Helium's about 5. Nitrous oxide is about 2, methane's about 2, xenon's about 2, and krypton's about 1 part per million. If you go all the way down to O3, you see, in fact, it's less than 1 part per million. I'll give you a more exact figure on a later screen. But basically, ozone is a very, very trace element. Okay, it's one of those things that, and originally parts per million meant the number of molecules per million molecules, or the number of atoms per million atoms. But now it just means, let's say, the number of kilograms, which is 1,000 per microgram. So something like that, where it's basically 1,000,000 to 1 in terms of pure mass. So you don't actually convert to the number of atoms and stuff like that anymore. But you can also see like nitrous NO, which I don't know which NO2 is and which NO is. I would say nitrogen dioxide is this one, and nitrous oxide is this one. Carbon monoxide, which makes an argument that this might be nitrogen oxide, but I'm not a chemist, so I can't remember those things. Those are also very, very trace elements. N2O, silicon or silicates, and NH3 happening, ammonia. Okay, so ozone is a trace element that accounts, there's the figure, accounts for 3 out of every 10 million atmospheric molecules. So that's, again, that's the way the parts per million is supposed to be, but we really don't use it that way. But it's still a pretty good estimate. So what we're saying is basically for every megagram of atmosphere, we have 1 gram or 3 grams of ozone. Okay, and actually in this case, it's for every, since it's 10 million, it's for every 10 megagrams of atmosphere, we have 3 grams of ozone. So it's a very, very small amount. So ozone is made through O2 combining with O and sunlight. That energy is enough to make them sort of wobble in such a way that the 3 molecules, the 3 atoms will come together to make O3. But the other problem is chlorine breaks down ozone through this process. Chlorine combines with O3 to make, I would call it chlorine monoxide plus O2. A single chlorine atom can repeatedly destroy ozone atoms because check this out. Once you have ClO and ClO, they combine with sunlight to make chlorine, chlorine, and O2. So now that chlorine molecule or that chlorine atom that just broke apart that ozone has now come free again and can do it again. And in fact, a single chlorine atom destroys about 100,000 ozone molecules. So you can do that with just basic what we call statistical mechanics, and you figure out, what's the likelihood of collision, how many times will this happen before this thing gets permanently sequestered, so on and so forth. And those calculations show that a single chlorine atom, which is at least one atom in every chlorofluorocarbon molecule, but every one can take out 100,000 ozone molecules. So that makes a problem for this very, very low 3 per 10 million counts of ozone. So because that's so many, we've really got a problem. The chemical industry argued that the theory was only speculative and that there should be no economically damaging CFC restrictions. Sounds just like the argument that was made for lead before this, and in fact was made for cigarettes, and now is being made for, it's a little bit less. I actually noticed quite a bit. And in this case, I'm going to mention, because right now the most recent politics was the Republicans not believing in global warming and not supporting actions against global warming, or in a more intellectual way. In some cases, they were just saying, we need to do this the smartest way we can so we don't destroy jobs. Okay. But you're going to see for this particular part of the story in ozone, the hero will be a Republican, and it will be Ronald Reagan. So I just want to point that out, that even though in the case of global warming, I'm going to repeatedly say things that you've heard Republicans say, and I'm not even going to necessarily point them out, but I just don't want y'all to feel like I'm trying to attack one party. We all do stupid stuff. So they said you shouldn't have any damaging CFC restrictions. Environmentalists argue that it's better to be safe than sorry. And ultimately, they staged boycotts. I saw one, I think it was like a Far Side cartoon or something like that. He said, but what if the scientists are wrong and will have made the world better for nothing? Which is pretty funny. I like that. But ultimately, they staged boycotts. In 1978, the U.S. and a few others initiated bans on CFCs and spray propellants. It was the least essential and only accounted for about 25% of CFCs. This was the first time a substance suspected of causing global harm had been regulated. So 1978, does anybody know who the president was at that time? That would have been Carter. Okay. And Carter was is a nuclear engineer. He went to, I think he went to Annapolis, the Naval Academy. But anyway, he was a nuclear engineer. He knew it. He still knows his science, 97, 98-year-old man running around building houses, which he hasn't been doing for about 6 or 7 months or a year now, but still pretty kicking it. So he did this thing internally, but not on a global scale. So that's right now he did that, but he's not the hero yet. The problem is it was least essential and only accounted for about 25% of the CFCs. So he was nicking away at it, but he only took up about a quarter of it. That's why he's not yet the hero. Okay. In 1977, a British atmospheric team noticed that the ozone above Antarctica dropped every spring and returned to normal in the fall. They were like, okay, this is kind of weird. And in fact, it was such a huge drop that they thought their instruments were faulty. Since 1956, they had observed the fall getting greater every year, and it reached 40% drop by the year 1984. Again, like I said, they were skeptical, and they delayed publication for years to check and recheck, make sure their instruments were calibrated, make sure they hadn't made any errors. And in 1985, they finally made their report known, and their report was greeted with skepticism, and critics suggested it was part of a natural cycle. So they said, oh yeah, this is just something that happens every 10,000 years. It goes up, and then another 10,000 years is down, and then another, so on and so forth. So they look for sort of indicators of ozone depletion and stuff like that. Mainly indicators are other things that you can use to measure ozone in times where we weren't there. We have things like that for carbon dioxide as well. And whenever you see a variable that correlates well with, say, ozone concentration or CO2, then you can use that as a stand-in argument for, well, this particular quantity is high, so that means ozone's high, or this particular quantity is high, so that means ozone's low. And they can quantify it that way. So that's really how we do the science of understanding the past before we made measurements about ozone and CO2 and lead and stuff like that. In October of 1985, Susan Solomon organized an Antarctic expedition and found that the ozone was now 50% below normal, and there were high levels of chlorine present. There was an ozone hole. She even suggested a mechanism, because chemical reactions don't take place in a gaseous state. Just like I was telling you about the nebular hypothesis, gravity don't pull things together when they're gases. It can't, because the gases are too strong, or the speeds of the gases are too strong. But if you get them down to at least a liquid state, then the molecular forces, and in the case of the nebular hypothesis, the gravitational forces can pull them together. So she actually suggested a mechanism involving ice clouds acting as surfaces for these reactions. And she really was the one that stuck the nail in the coffin, because check this out. This is a second expedition in 1987, confirmed her predictions, and these are her predictions. Check this out. The chlorine monoxide that we were talking about earlier, ClO, chlorine and one oxygen, that actually was found to correlate nicely with the ozone depletion. So the green is ozone parts per million, and the black is chlorine parts per billion, okay? So it was a much smaller amount, but what we had here was, here is a potential cause of ozone disappearing, namely CFCs breaking down into free chlorines that attacked O2 and made chlorine monoxide. And when chlorine monoxide was there, that would break loose and set the oxygen free to make O2. And therefore, you had a possible cause and effect, but not completely. You know, post hoc ergo propter hoc is actually a fiction. It's not necessarily true. Just because A preceded B does not mean A caused B. One example of this was in the early 80s. My grandmother was diagnosed with Alzheimer's disease, and one of the first things they started discovering about the brains, because MRIs and various other things were coming on board, was that it turned out these dead patients, people that had Alzheimer's disease, had high contents of aluminum in their brain. It's a neat sidebar. When you're doing MRIs, most people say, oh, wow, look at the cool pictures. And the cool pictures are great, but you actually get a spectrum from it, just like you do from a star. And that spectrum is little spikes and stuff like that. And each of those spikes is like a fingerprint, because it has a very specific energy / frequency / wavelength. And that corresponds to certain elements. So what they were finding were these little spikes in the slot where aluminum would spike in the brains when they did MRIs and stuff of that sort. So they started thinking, oh man, maybe aluminum is the cause of Alzheimer's, and people started getting rid of their aluminum cookware. They were starting to be afraid of drinking out of aluminum cans. Well, again, that's a post hoc ergo propter hoc thing, and it's a correlation thing, but it's not necessarily showing causation. Ultimately, we learned that the aluminum in the brain and the fact that people had Alzheimer's were both sort of caused by the same thing. So they had a mutual cause, but the aluminum didn't cause the Alzheimer's. Okay, so all that stuff was debunked. That's wonderful. We went past that. But when you have this sort of thing, when you have a correlation but not a causation, how do you actually show it? Well, here's another neat story. In 1998, the day before my 28th birthday, June 2nd, I got in a bad car wreck, and this person just didn't understand. They literally were 2 weeks into the United States. They had come from Japan. She didn't understand that, left turn yield on red or whatever, and just plowed right under my Jeep and flipped it over. And it was, pretty traumatic. I broke my back and all sorts of stuff like that. Had a huge amount of pain, but it was kind of neat because I learned of this medicine called Neurontin, which was the brand name and was quite expensive at the time, but now it's a generic. Anybody heard of that medication? my little Chihuahua, because he's so small, it's one of the few pain medicines they can give him. It's called gabapentin. So that's another medicine. Well, this is a tailor designed drug that they made to treat epilepsy, people having seizures. And they worked it to, they manufactured it and designed it to be the type of drug that can keep you from having seizures. And it works. It's just not that good. It turns out to be a pretty crappy anti-epileptic. But if you have someone that's allergic to the others or has bad reactions to the others, you can use it and it will give them some help. But what they did find was that a lot of patients were saying, well, it didn't really help my seizures, but I tell you what, man, this sciatica I had just gone right away, or this knee pain I had just went right away. And that's why I was prescribed it, was for the chronic back pain I was getting from my broken spine, which they didn't find, by the way, for 6 weeks until 6 weeks after the wreck, because I was up in Chapel Hill with my other quote unquote tree huggers. And they were like, well, I don't believe in x-raying, young people unless they really, really need it. So they didn't x-ray me. They didn't find out I had a broke back. And then, in fact, they gave me the worst advice. They said, stop running, start riding your bike. Man, I rode my bike one day instead of running. And I ended up being in bed for 4 days after that because it hurt so bad. But anyways, how do you go from that looking like Neurontin / gabapentin helps pain to proving that it's actually the cause of that decrease in pain? Well, what they do is they say, okay, I'm going to take 1,000 patients, or let's say I'm going to take 5,000 patients, and 1,000 of them are going to get placebo. Another 1,000 are going to get a popular medication for pain. And then a third 1,000 will get 100 milligrams a day. A fourth will get 200 milligrams a day. And a fifth will get 400 milligrams a day of Neurontin. And it's double blind, so neither the doctor nor the patient knows what they're getting. They have numbers, and a computer keeps all that in check, and then you just blindly report all those things and does the analysis, and then the computer tells you which one's which later on. That's the way double blinding works. And it's not because scientists are necessarily crooked or anything like that. It's just even the best scientists, when they are working their hardest, they still make this mistake. There's these studies that show that when company A supports the research of a researcher, their product tends to do better than company B's product, unless company B is supporting the research. So they've got weird things like that. And even in double blind tests, they come out that way. So there is some reason to do that, even if it's subconscious. So when they get the data back and they see, first off, the low-hanging fruit, so don't let these pseudoscientists and homeopathy type people tell you otherwise. Homeopathy people will argue that it's as good as placebo. Well, placebo is sort of the not good. It's the thing that didn't happen. It's basically, Carl Sagan said that 70% of all maladies will, if left alone, go away on their own. And if you happen to have been taking a placebo and you happen to have been one of those 70%, you might think that placebo was really good. And so that's what we use as our sort of no function. This is the thing that shouldn't show any effect. So if someone compares it to placebo, immediately walk away and know that's a pseudoscience. It's nothing to be listened to. So the first thing they do is see, does it do better than placebo? It turns out the best medicine in that second 1,000 people, that did better than placebo. So did all the other three. Okay, so everything did better than placebo. Now here's the kicker. If you found that out of that 1,000, let's say 600 felt less pain, reported less pain in the Neurontin, or excuse me, in the most popular medication, then you say, okay, well, the most popular medicine does work. Well, if you want to stand it up against gabapentin / Neurontin, then you say, oh, well, look here. Now, after this analysis, I find that the 100 milligram patients of Neurontin actually, instead of having 600 report less pain, 700 reported less pain, or maybe some other numbers or whatever. But then when you went to 200 milligrams per day, the effect doubled. And if you went to 400 milligrams per day, the effect quadrupled. If you see that, then you've proved causation. Because when it zagged, this one zagged, or vice versa, or whatever. So doubling the action doubled the result. That's a good indicator of causation. And that's what this graph right here is showing down at the bottom. Notice when there is a positive spike in chlorine monoxide, there's a negative spike in ozone. And then when there's a negative spike in chlorine monoxide, there's a positive spike in ozone. That's particularly beautiful. And no, she didn't win the Nobel Prize. Those two other guys did. I think it's perhaps uterine bias with the Nobel Committee. But anyways, this is what she did. This is what proved the smoking gun, if you will, of ozone, is this causation graph right here. So in 1987, now we're up to what president? Remember in 1989, this man said,
Ronald Reagan.
There you go. Yes, yes. He said, tear down that wall. That was 1989, and you know he ran for 8 years, or was president for 8 years. So yeah, 1987 was Ronald Reagan. And in Montreal, 47 nations signed the Ozone Treaty. And of course, the sagacity of the treaty was spearheaded by the U.S. So again, Ronald Reagan happens to be the hero in this one. And it was definitively confirmed with her stuff. In 1995, Rowland and Molina won the Nobel Prize, and Susan Solomon got a nice little quote in my text, in my demonstration in the textbook. So the treaty was comprehensive, and the chemical industry moved rapidly to develop replacement chemicals. Now, you can't always do that. There might not be. I mean, science doesn't owe us crap. So the fact that we like refrigerants like CFCs, and we found CFCs and they were refrigerants, doesn't mean there has to be another refrigerant in existence. Okay. And it doesn't mean that we can necessarily chemical engineer another Freon type particle. So we're not promised anything, but if we're lucky enough, then the search for it can spawn a whole new industry. And if we actually find one, that can spawn a whole new industry. And in fact, people can make a lot more money. I now have several friends who are charging $75 a pound for Freon in old units, whereas you can buy a whole 20-pound bottle for around $80. Okay, so that's industry making use of old Freon. And now the new stuff, which is dirt cheap, has a huge industry completely built around that. So a lot of times these things that look like they're going to be a financial disaster can turn out to be an actual boon. And that's what happened with ozone. Now, that being said, the ozone is not expected to recover and reach safe levels until around 2050. In 2010, we were actually a little bit slow on that, but now we're back caught up from my most recent searches. So it looks like we're right on task for being that, for reversing that by 2050. The ozone hole has still not appreciably improved. That was roughly 2010 when I made this. It has improved, but not a whole lot. Okay, so I think it's maybe 80% of the size that it used to be. So it's maybe went down 10 or 20%. That's about it. Additionally, oh, by the way, the US EPA predicted that 12 million excess US skin cancers and 200,000 resulting deaths from 1987 to 2050. Now that stat actually were way faster than we thought. So the US EPA and National Institutes of Health and the CDC and all those people were actually being a little conservative. So they predicted actually smaller numbers than actually happening. So we are on pace to go well over 200,000 resulting deaths from skin cancers alone as a result of this ozone hole. Also, you expect increased cataracts, immune suppression responses, premature aging. I don't know if you know this, but I'm only 24. This is what's happened. I'm not really 24. I'm 32. Yeah. Okay. Additionally, crops, microscopic organisms, and near-surface living fish will be depleted to some extent. So those are some of the scientific impacts of ozone. But this curve is really remarkable. This was the curve historically. But then you get around here and you see, okay, 2015 chlorine returns back to safe levels. This is what would have happened without the ozone treaty in effect. The predicted future concentration of free market had remained in effect till 2010. And then they say, okay, well, 2010, I'm sure we would have took action. Then it might have fell down like this. But literally, if Reagan hadn't taken that action when he did in 87, we might have been here 10 years ago. As it turns out, we're actually, at this year, we're right about on task, which would put us right about here. Okay. So, to is global warming. So I've given you a sort of a story, if you will, of how ozone depletion went, how the industry argued. Now I'm going to do sort of the same parallel with global warming. Does anybody have any questions before I jump into that? So I gotta make some pretty harsh statements here, specifically because I know a lot of good people that I love, family members, friends, and stuff like that, have said some of these things to me. So I got to make sense of it. I once talked to a person who didn't believe in global warming, and when I asked him why, he said, "I don't think God would put us on the earth and then let us destroy ourselves like that." And
You're kidding, right?
What's that?
The student was kidding, right?
No, this wasn't a student. This was a close personal friend, a grown ass man that said that. But in some sense, I get that. God, if God exists, He's going to be this awesome. Maybe He'll be this awesome father figure that would protect us from something like that. So I asked him. I said, because it bothered me so much that he answered that way. I said, well, do you think? Because I remembered, Reagan and what was going on with Reagan and the end of his term. And I said, do you think we could destroy ourselves with nuclear weapons? He said, oh, yeah, absolutely. I said, so, but God was going to let that happen. And he said, oh, and he came back like 2 days later and he said, okay, I think I believe you. I think I understand what you're saying about global warming, but what can we do about it? I was like, okay, well, that's good. That's a really wonderful argument because, yeah, there's a lot of bad answers to global warming. And guess what? I say us, I'm not really a Democrat, but here in Currituck, I'm considered like a flaming liberal communist. I'm not really either, but like I said, in this area, I am. So Democrats are notoriously good at making really bad decisions, okay? So we might actually, we being again us, might actually make something bad here, but that's something that's reasonable. You should be able to talk about what can we do to not destroy humans all over the world and specifically in the United States with regards to our politicians, but help global warming. So here's the big issue. In 1543, Copernicus is on the revolutions of the heavenly spheres, was part of it spawning the scientific revolution. In 2014, many parts of modern civilization have not yet experienced a revolution. In short, if you're trying to use reason, logic, and science to inform your opinion, which I would hope everybody is trying to do that to me is a post-scientific revolution mindset. Let the data tell us what is true and real, and let's act accordingly using logic and reason and sympathy. I mean, you got to use sympathy too, because you can't just say this has to be done even if it kills 400 people. We're not Machiavellian, or even if it kills 500,000 people or something like that. So you must be able to answer the following question. What data or evidence would you need to see to convince you of anything? If there's anything that you say that nothing, no data, no evidence would ever convince me of A, then you're not being scientific no matter what. I can list a ton of data or a ton of experiments or a ton of findings that would tell me evolution is wrong. Okay, 100% I'd say Darwin's wrong. Okay, same thing with general relativity, which is what I did my research, my PhD research in, but didn't get very far, and all that good stuff. So you should be able to find some evidence or some kind of data that you need to see to convince you of anything, period. Okay, if you're not doing that, then it's you're not being scientific. You're just sort of being more of a faithful. You're literally believing in some higher ideal than what the world could show you. And just to be honest with you, that's exactly what Aristotle and everybody that followed Aristotle did. So I can't say you're an idiot for doing that. That's absolutely not the case. What you have to say is, no, you're being faithful to some ideology, and that certainly is your right to do. It's just a matter of, do we do that as a government when there's so many different ideals for so many different people? So what data or evidence would you need to see to convince you of? For instance, if you answer there's no data that could convince me of blank, or if you suggest data that only God could provide or gather, then you're not being scientific or rational, you're being faithful. Okay, you're being faithful to your beliefs. And in that, I'm saying faithful, I don't mean it necessarily in religion. It could be religion, but it could just be, there's no way that there's more than one gender, or there's no way that there's two genders. That would be a statement that might be true, might not be true, but that's something that if if you say that, then you're basically saying no evidence could ever show you that, and that might not be the case. And then when I show you a hermaphrodite, you'd say, well, that's clearly a man. But anyways, so there's nothing wrong with being faithful unless you, of course, cause atrocities or something like that, which is not unlike what happened with the kamikazes, which is not unlike what happened in the Crusades, which is not unlike what happened to Giordano Bruno, Joan of Arc, and as you see here, Galileo. You know, these were atrocities that happened when people were acting out of their ideology as opposed to what reason says. If you want to see more stories, horror stories of this, look up a book called Malleus Maleficarum, and that's called, that Malleus means hammer, and Maleficarum is another word for witch. So Malleus Maleficarum is the hammer of the witch, and that was a treatise written by someone in the Catholic Church of how to torture people to find out whether or not they're witches. And you will read a lot of horrible things, and that's what they did. And in fact, they set it up in such a way that you only got positive results, meaning if they died, oh crap, they weren't a witch. Oh well. But if they didn't die, then they were a witch. So you can see a problem with that, right? But they just went with it anyway. So there are things that happen like that. It's really, really terrible. Again, that's sort of, you know, pre-scientific revolution. That's why I say the modern scientific revolution mind would basically say, no, let's see evidence and data before I go do A, B, or C. In fact, one time the Dalai Lama was arguing to Bill Clinton. Now, this is kind of neat. Bill Clinton said, well, what about this? He said, well, the difference is you folks have had a scientific revolution. Our culture has not. And that's a big deal. If you haven't really gone through the scientific revolution, whatever place you live in, then you're not going to see it that way. And that's what he was arguing about, certain groups of people behaving badly. So ask yourself three questions. What data or evidence do you need to see to convince you that the globe is warming? What data or evidence do you need to see to convince you that it's not just a natural or cyclic process? And what data or evidence do you need to see to convince you that the current global climate change is mostly a result of humans? Okay, those are the big things that you need to think about. Okay, if you can't answer these with data, then that's fine. It's just I'm never going to be able to convince you because you're not using science and reason. So I have a piece of data in here that most people don't know. I've never heard it on any reputable news stations other than NPR and the BBC. Okay, I've never heard it on CBS. I've never heard it on NBC. I never heard it on MSNBC. I haven't heard it on Fox. They never talk about it on OANN. I've never seen it on Newsmax. New York Times, I've read it in, which is nice. And the Washington Post, I've read it in. And various other newspapers I've read it in. But I've never seen it on broadcast news except for NPR and BBC. So it is a common misconception that the greenhouse effect is a bad thing. If it wasn't for the greenhouse effect, the Earth would be 33 degrees Celsius cooler, or 59 degrees Celsius Fahrenheit cooler. That's actually in the negative temperature range, so that would be bad. Water in the liquid state would not exist on the surface of the Earth. Your book does this calculation and shows you the equilibrium temperature for the Earth. You can actually look that up and see exactly what that is. And that calculation works for the planets except for Mars. Well, actually, it works pretty well for Mars, but it doesn't work well for Venus or for Earth, and that's because of the greenhouse effects. The greenhouse effect is not due to copious amounts of oxygen and nitrogen. It is mostly due to trace amounts of nitrous oxide, carbon dioxide, and methane. In fact, nitrous oxide accounts for about 6%, CO2 about 82%, and methane for about 10%. Now, I've given you footnotes on that, but I'll tell you methane is in some sense a more efficient greenhouse gas than even CO2. But again, like water, which is also a slightly more efficient greenhouse gas, methane and methane and water we have to have. So there's nothing we can do about that. The water vapor content of our atmosphere is basically measured by humidity. It has a natural maximum. Once you reach that maximum, we have, like we learned yesterday, one of our students realized that was precipitation. So this is the energy breakdown. And basically what it shows is that when incoming radiation comes in, about 25% is reflected by the atmosphere, about 5% is reflected by the surface of the Earth. The other, basically that was 30%, the other 70% is absorbed by Earth and then re-radiated. And if there wasn't for a greenhouse effect, it would be negative 19 degrees Celsius. And that's about what your book gets when it did a calculation of the equilibrium temperature of the Earth. This is what it happens when evidently someone puts a bowel movement in the sky. Now, that's supposed to be clouds, actually, but it looks like a bowel movement that I've seen on x-rays before. So what really happens is that 50% that absorbed by the Earth then comes back out. And when it comes back out, it actually interacts with the clouds. Not only that, instead of the full 70% going into the Earth, about 20% gets stopped by the clouds and re-radiated by the atmosphere. So you end up getting in this little cycle where then the ultimate 70% does come out, but because of this, we actually get a nice cool or a nice natural 14 degrees Celsius. So that greenhouse effect was really nice. It helped us not have liquid or not have only solid water on the surface of the Earth, which was pretty critical to every model we've ever seen about how life may have existed. Okay, again, in the scientific realm, there's other ways that you can just say man's here and we're fine, right? So global warming, basically polyatomic molecules made up of 3 or more atoms are greenhouse gases because they vibrate just right so they can absorb greenhouse gas. Mars has no greenhouse effect because its atmosphere is too thin. It's too cold to sustain life, and it's so thin that water just boils anyways. Venus has a runaway greenhouse effect, which I talked about before. For hundreds of thousands of years before the Industrial Revolution, circa 1750, carbon dioxide levels had stayed around 280 parts per million. You're probably asking, how the crap do they know that? The peak was 300, and that was about 325,000 years ago. How do we know how much CO2 was there? Well, you can do things like, well, this isn't dendrochronology because dendrochronology only gets us back to about 30,000 years. But there's ice cores. Each layer is like a new layer on a tree, and you can go back and count the years that way. You can actually look and actually match other ice cores that are deeper by the behaviors of, say, the last 10, which would be the top 10 on this other deeper layer. When they match, you can say, okay, well, these 10 years must correspond to these 10 years. So then you can go deeper and deeper. And some cases, you can literally take samples from inside the, the ice core and get samples of the atmosphere. Sometimes you can have traits, like in the case of dendrochronology, certain rings have certain thicknesses that are indicative of this, and other species have other things that are indicative of this. So all these things are stand-in variables that allow us to account for CO2 parts per million, as well as for ozone and things like that. So today they're around 414. This is what I was telling you. It's went up to about 420 now. Molecules of CO2 per million. Again, that's molecules per million, but in reality, it's grams per megagram. So basically, we have 414 grams for every megagram of atmosphere. That's an increase of over 47%, and that's, of course, an increase of just from 1750. This is an actual graph. This is sort of one of the ones that the people call the hockey stick, and you've probably heard some books written about the hockey stick saying it's false and all this stuff. It's not, and the reason I'm most confident about that is a guy by the name of Mueller, Richard Mueller, not to be confused with the guy that just did the Russia report, but Richard A. Mueller. Let me stop sharing for a second, and let me stop sharing. That's what I want to do. So, Energy for Future Presidents by Richard A. Mueller, the science behind the headlines. He also wrote Science and Technology for Future Presidents. This guy was a global climate change skeptic, and he basically got a grant from what are those brothers, the oil people? Dang, I can't remember their name now. Anyways, he got a grant from them, and to their credit, they did not pressure him in any way, and he admitted that. His idea was that the globe was not warming, that the hockey stick was an anomaly, and it was an anomaly because they had put these pressure or temperature and weather sensors all over the planet Earth. And since that time, which has literally been like 60 years, a lot of those places have become more urbanized, and they expected that the blacktop was actually making the temperature seem higher than it was. I hate that I can't remember their names. Anyways, he was given a big grant, did the research, discovered that his estimate of how much they needed to subtract from the temperature readings at various locations was actually smaller than the number they did subtract, because they actually knew that science a little better than he did, and they took some things into consideration that he didn't take into consideration. And then he was called before Congress to report his findings. And lo and behold, he said, yeah, it turns out the hockey stick's right. So I would say that's one of the single best pieces of data. It's not the one I was telling you about that I haven't seen on Fox News and all that stuff. I haven't seen on MSNBC or anything, but it is still some fairly good news. Anybody know the brothers I'm talking about? God, it's bothering me that I can't think of their name.
Are you thinking of the Koch brothers?
Koch brothers, yeah, that's it. Koch, yeah, thank you. One of which recently died, but yeah, the Koch brothers are the one that gave him that. And like I said, they were really super awesome in that they didn't pressure him. So I'm completely on board with that. Another reason I believe that the global warming thing is not a hoax is because, okay, y'all are looking at this right, is because the Koch brothers, who put hundreds of thousands of money into grants, they can easily write a grant for someone to create a global circulation model. I mean, it would cost maybe $200,000, and you could get probably 3 grad students and a PhD working over them to write a really good one. You could probably spend $300,000 or $400,000 or even $1 million and get 5 different ones. It's really that pretty straightforward. But everyone that has ever written a global circulation model, and that's what they're really called, they're not called global climate models, everyone that's ever written one of those, once it goes through all the tests, and the tests are like, does this obey conservation of energy? Is there some area where energy is being created or destroyed? Does this obey the laws of physics? Does this match the data on the ground? You know, if you've got air against blacktop, is the energy transfer like what we know from studies of blacktop over air over blacktop, stuff like that? And then, does it predict the past from the previous past? In other words, you go back, say, 50 years, and you take the conditions 50 years ago, and you feed that data into your global circulation model and predict the next 50 years. Can that global circulation model accurately predict those next 50 years that we now have the data for? And yes, they can. And in fact, that's the first test they do after they do all the you know, does this obey the conservation of energy? Does this obey the law of physics? The next test they do is test it on the weather we've already seen. And yes, if they don't pass that, they don't get even published. Okay. So that's why these global circulation models are so powerful. And everyone that ever passed that test, always, when you feed the current projections of CO2, also predict the current increases in temperature that we're seeing by like this hockey model, which is actually the hockey stick model is really this CO2 amount, but this is the actual temperature as well. So again, that's not the data that I'm telling you I've only heard on NPR and BBC, but this is another grandiose point. How come the Koch brothers or anybody else hasn't funded a global circulation model that ultimately showed that the temperature doesn't increase? And the reason has to be because it can't. You know, if you make the laws of physics and apply it, and it predicts what we saw in the past, it's not going to predict that there can't be global warming, because global warming seems to be a fact. The fact that it's anthropogenic is another situation, which we'll show as well. Okay, so this is it for the last 2,000 years. This showed a couple hundred, 1860 to 2000. This one showed back 1,000 years ago. This one also shows back 1,000 years ago. There's a medieval warm period in here and stuff like that. But this is degrees Celsius, and we see that we're roughly in this area. We had before this, before 1986, I think we had a maximum in the medieval warm period, but we exceeded that back in, I want to say 1986. This has some corrections to it, so it's a little bit different. But anyways, so couldn't this just be a cyclic process? Well, yeah, but when we look at it, it doesn't look like it's cyclic. It looks like it's cyclic up. In other words, it's like a wave, but it's a wave whose midline is increasing. So it goes wee. So that's another part where they spin it saying it's cyclic. It doesn't appear to be cyclic, and we can go back farther than 2,000 years and see that. When we look at carbon dioxide, again, using those flag indicators where they correlate with CO2 concentrations, this is it going back 10,000 years ago. and then look at it. Just in this area alone, it took off. And again, this was just showing a top of about 370, or excuse me, about 377. We're now above 420. Okay, or we've now reached 420, I should say. And if you zoom in just from 1800 to 1750 to that, that's what it looks like in the 1750 to now period. This is what it looks like 10,000 years to now. So you see, this is a huge, huge, huge increase in CO2. So I said, okay, I agree. CO2 can cause an increase in temperature. I also agree that temperatures are rising despite what is supposed to be the little ice age. That's one thing I wanted to mention to you. Due to the Milankovitch hypothesis, which I talked about last time, we're currently supposed to be in an ice age. So when you hear people say, just not too long ago, scientists were saying we're in an ice age, they did. That was exactly right. But that's sort of even a better arguing point, is because our temperatures, our global temperatures, are supposed to be on the down low. In other words, going down. Down low didn't mean what I thought it meant there. But they're on the down trend because of global, actually, solar system issues. It's supposed to be on the downtrend, but it's not on the downtrend. It's actually on the uptrend, and that means it's literally overcompensating for Milankovitch hypothesis. So also, I can see that the concentrations of CO2 in our atmosphere has sharply increased since the Industrial Revolution, circa 1750. But does that does not prove that fossil fuels are the culprit? Additionally, the increase in CO2 concentrations just correlate with the Industrial Revolution. Correlation does not equal causation, no more than gabapentin takers feeling a little better was caused by the gabapentin, right? So if only there were a way to identify the CO2 molecules humans have produced, then we would be certain that the global climate change is a result of humans, i.e. anthropogenic, okay? It seems that humans produce CO2 mostly through burning of fossil fuels. Wait, that means fuels made from fossils, right? Fossils, anybody know how old fossil fuel is? Just a rough estimate. Maybe 65 million at least, because we knew the dinosaurs walked the earth 65 million years ago, right? And in fact, it's actually older than that. Most of the stuff we're getting, or at least the stuff we were getting in from Saudi Arabia and the Middle East, that sort of area, that was considerably longer ago. I think the shales are a little bit younger than that, that we're getting here in America. And that is really the big thing. A lot of people see, oh man, we've got the time, we've got the chance to be richer than Saudi Arabia and Kuwait and these various countries like that with our own stuff, because we now have the technology to pull it out of the shale. And that is actually, by the way, younger. If that's the case, then we really need to do that. But the problem is we came a little too late, and we came a little too late because gas was never that expensive before. People have known about doing this type of mining since probably the 70s. But they knew it would never be helpful because oil had to be at $100 a barrel. Well, oil didn't hit $100 a barrel until a couple of decades ago. That's why this fracking mechanism started. So because that fuel that we use is made from fossils, right? The way this works is basically fossils, let's say plant life, animal life, bogs like you see over by the Science Museum or the Marine Museum over in Virginia Beach, that muddy, boggy type place. That's the type of environments that become future coal and gas and petroleum stuff. So when that fossilizes, basically what happens, these things that take in oxygen, atmospheric gases like animals, they take in atmosphere with exactly the CO2 concentrations that the Earth has at that time when they die. But the instant they die, they're no longer replenishing the CO2 in their tissues. So the CO2 in their tissues is made of carbon and 2 oxygens, and carbon has a small fraction of the carbon that's actually in the form of the isotope carbon-14. That carbon-14 has a 5,730 year half-life. So every 5,730 years, that carbon-14 in CO2 is going to become something else. So it's going to decrease. And the rule of thumb is usually 3 half-lives means it's gone. But you can really still detect it at about 5, maybe even 6 half-lives. But even at that, you're still only talking maybe 40, 50,000 years. So we can't expect any carbon-14 to exist in fossil fuels. That's the big kicker. This is the data I told you that the NSF gave me, and various other scientists can tell you about, that you never see in any of the broadcast news, except for, like I said, NPR, and I heard it once on BBC. But this data says if the carbon dioxide problem that's going on right now as a result of fossil fuels, you'd expect the CO2 in our atmosphere to have very little carbon-14 in it. So yes, that is what it means. So if we could see how much of the carbon in CO2 is carbon-14, then we could estimate the fraction that is a result of humans burning fossil fuels. And what does such studies reveal? Well, I do a sort of back of the envelope calculation. I say, consider 1 quintillion molecules of the atmosphere. There are currently 388 parts per million. Again, that needs to be changed, but this is a calculation I did, so I left it.
2 minutes left.
Yeah, thank you, bud. Of those molecules of CO2, about 388 times 10 to the 14th are carbon dioxide. So that's the 388 part per million. Out of 1 trillion atoms recently created, carbon-14 is a atom, is one atom. So the 388 parts per million of CO2 were not a result of fossil fuels. You'd expect 388 of the carbon dioxide atoms to be made of carbon-14. So that if it wasn't fossil fuels. What we actually find is that about 200 carbon dioxide molecules made of carbon-14. So what if all of the 108 parts per million of carbon dioxide were from fossil fuels? Well, then you'd expect about 202. So we're basically saying you'd expect 202 if it was all caused by global warming, by anthropogenic use of fossil fuels. We'd get 202 parts per million, but we get 108. Okay. Therefore, it seems the new carbon dioxide is mostly a result of fossil fuels. And this is where it talks about, some people have doubts about carbon dating, and basically I would just tell you they're wrong. Okay. Not only that, we have multiple lines, so they can make arguments about carbon and stuff like that. And carbon doesn't always work. For instance, if something's under the ocean, it's not going to get the same amount of CO2 as it does when it's in the air. So often people with like Answers in Genesis and other groups that try to change the narrative will say that carbon-14 dating doesn't work because they point to some clams at the bottom of the ocean that were supposed to be older than the universe. Well, no, that was some idiot doing a carbon dating on something that shouldn't have been carbon dated. It should have been dated with something other than carbon, because the amount of CO2 concentration in the ocean is entirely different than the CO2 concentration in the air. But I wanted to show you that the Earth does have a way to correct. This is all the models. These are the models, is all this. This is the actual data. And you can see that basically all of them fall within the error bars of the data. What I wanted to show you is when you do the model and use only natural variations, the actual observations are the straight line, but the gray area is the models. So that's what it does when it's only natural. When you do it with only humans, notice how much closer it sticks. It does get a little low there, but then it sticks pretty close. But when you take both the natural and human causes, it matches really perfectly. So you can see, yes, human alone is closer to the reality than natural alone, but it's not the whole deal. And in fact, the natural gets almost nothing towards this end, whereas the humans get all this, say, from the last, let's say 30 years. So that's another smoking gun. That puts us on the edge of, let's say 85% to 95% of the cause is humans. Something else I want to say is, yes, the Earth has a natural way of getting rid of it, but this is the way. When the CO2 gets too high, it gets too warm due to the greenhouse effect. Warm weather results in rain, like rainforests. Well, that rain takes some of the atmosphere with it, and some of it makes it into the ocean, some of it makes it on rocks. Some of that in the ocean and some of that on the rocks is actually absorbed by the rocks, and then the rocks are pushed underground, and therefore the CO2 is sequestered. And slowly, the CO2 concentration goes down. But you're literally waiting for rocks to dissolve gas. and then to sink under the surface of the earth. Okay. So that's the mechanism for taking out CO2. But then when it gets not enough greenhouse effect, just like in the winter, you're always getting shocked by wiping your feet on the carpet because there's no water in the air. Well, when that happens, slowly over time, those rocks that have been subducted down here will actually come into what ultimately is a volcano. Those volcanoes will off gas that CO2, and the CO2 will start to build up again. So yes, we have a mechanism that the earth can fix itself, but it's a very, very slow process. That's why we can't do it. Okay. So that's the end of that topic of global warming. I would invite anybody to ask questions. Time is essentially up, so you are free to go. Remember, we're meeting at 1:30 for lab. The lab's already there though, and you're not required to be there. I'm going to be there to answer any questions, but then I'm going to let you guys go on and do your lab. So I'll wait for the last person to leave, and everybody else, have a good day. Have a good weekend.
Have a good one.
You too.
Professor, I do have a question about
Yes.
taking the midterm later today. So I'm just going to wait till everyone else leaves.
Okay, no problem. Amy or Matthew, did you have any questions?
I just had comments. It seems like this is the passionate topic of this course for you. I wanted to know why it hit home so much, because this is the one I've seen you be the most passionate about so far in the class.
That's actually a good question. Actually, lately I've been, I was always a person that sort of just voted my conscience and always have. And up until, I guess, this last election, I had voted 50% Republican, 50% Democrat. But I really started paying attention to politics when probably when Bush was coming into office and running against Gore. And that's when I noticed a stark disconnect between politics and science, and what I thought was purely dishonest. I mean, I've been listening to Rush Limbaugh since 1988, watching him on TV, literally. So I leaned a lot towards the right in some sense. But when I saw them blatantly lying about what I knew was true, I got really, really passionate about that. And that's the deal with global warming. I know it's a big thing that can cause a lot of problems for future generations. And it happens to be in my wheelhouse of politics, where I've caught people lying. I caught a lot of people lying about the ACA, so I'm also passionate about that. I caught a lot of Democrats lying about mental health issues. I'm passionate about that. But yeah, that's probably the main reason. Is it's a confluence of my knowledge with politics, which is also very interesting, with just dishonesty that makes me mad. In some cases, it's just ignorance. I went to a Christian school that was very, very conservative, and they told me a lot of things that I know now are false. And in those cases, I don't think any of them lied. I think every one of them, teachers that I'd grown up with and that like I babysitted for, ones that I remember hugging, like when I was in, first and second grade. And I just felt like they loved me like an aunt or a sister or brother or something. I know they didn't lie to me. I just think they believe that too. So a lot of it's not lying, but it is something that needs to get right.
So you're just trying to make sure that we know what's right and what's true before we get influenced by politics?
Yeah, exactly. And I can give you sources, really good sources that are fighting the actions against global warming. In other words, they are actually fighting what a lot of the quote unquote Democrats are doing. Okay. But they have a really good argument that's scientifically based and is exactly correct and exactly the right argument to make. I follow a couple of them on Twitter, and it's just wonderful to listen to those. And that's the kind of people I'm cool with, and they are ultra conservative in many ways. Some ways they're just moderately conservative, but at least on the science, they're getting the science right. So I will give you tons and tons of people that are doing that right, and they are on quote unquote the right. A lot of people might say they're not the right. Like, there's a big band of people right now that says anybody that doesn't agree with person A is clearly not Republican or clearly not conservative. So other than that, I would say, yeah, they're definitely on the right. So yeah, I want to make sure y'all know the real science. I wanted to give you that evidence that, we don't get from MSNBC, we don't get from Fox, and that sort of thing.
All right.
Thanks, Amy. Yeah, Matthew.
I kind of forgot what I was gonna ask.
Yeah, I talk a lot. That happens.
I'll come back to you for the lab and ask it.
Yeah, that's no problem.
Goodbye.
See ya, Amy. Thanks for coming, everybody. I'm gonna sing a song in a second, Jamie. I think we're alone now. There doesn't seem to be
Cool song.
anyone around.